Hey guys, welcome back to Pre-Calculus. It's Monday, April 27th. It's good to see you guys. I know you can't actually see me. I can't actually see you. But it's nice to just think that you're out there listening to me and I'm seeing you in the classroom and all is normal, right? Well, anyway, let's get to our Monday lesson. So today we're going to do a little bit of Algebra 2 review, talking about complex numbers. With complex numbers, I didn't type this on here, but a complex number is a plus bi, where a is the real number and b is the complex number. This one's real. Oh, let's see. Get a different color. Here we go. This is the imaginary number. Okay. And remember that the imaginary number, I, equals the square root of -1. So it's a number that can't be square rooted. So any number underneath a square root that is negative will be imaginary. The biggest thing that you're going to use today is the I squared equals -1. Which, if you square both sides of the imaginary number, then that's what you would get, I squared equals -1. Okay, so everything we're going to do is review. And so I'm going to just show you 3 Delta Math problems. You have 3 different sections of Delta Math today. Each section is just a little bit different, so I'm going to show you what the Delta Math problems look like. So here we have, this is, if you see the title, this is the addition and subtraction of complex numbers. So I picked a subtraction problem simply so that we can distribute the negative on this problem so that we turn it into an addition problem. Okay, we'll distribute the subtraction sign. So what we've done is we've turned that problem into -5 plus 4i plus 5 minus 3i. And so if you want, you can separate the complex numbers. Here you have 2 complex numbers. This is a complex number. This is another complex number. And now it's just a matter of adding and subtracting like terms. So in this problem, your -5 and your +5 are going to give you a 0. They're going to add up to get nothing. And then you've got your 4i and -3i will add together to give you I. So 0 plus I, or probably just I, will suffice within Delta Math. So either one of these 2 become the solution to that problem. All right, so that's the adding and subtracting, which is really kind of both in one problem. Then we have a multiplication problem. You'll see this title is the multiplication of complex numbers. And so what we want to do is remember how to FOIL. First, outer, inner, last. So we'll take -6, multiply it by 2. That's -12. -6, multiply it by -3i. Gives you 18i. And then let's get a new color. -10i times 2 is -20i, and -10i times -3i is +30i squared. All right, so here, this is where I was talking about a few minutes ago. Very, very, very important right here. I squared equals -1. Anywhere you see an I squared, like right here, that I squared becomes a -1. So basically, this is 30 times -1, which is going to end up being -30. So all the rest of these numbers are going to just scooch down. -12 plus 18i minus 20i, and a -30. Combine like terms. So we have final answer, -12 and -30. Give you a -42. 18i minus 20i, -2i. We don't have to factor that. We just have to write it correctly as an a plus bi number. Okay, complex numbers. Okay, once again, I squared turns into a negative 1. 30, which is positive to begin with, times a negative 1, turned into a negative 30. That negative 30 combined with this negative 12 to give us a negative 42. Okay, so again, this is a review from Algebra 2. So we're just doing a little review lesson before we get into more complex number stuff on Tuesday. All right, last one. The division of complex numbers. This is probably the most complicated part. We get to multiply by what's called, oh, good gosh, what was that? A conjugate. Okay, and so if we have a standard complex number that is a plus bi, then its conjugate would be a minus bi. Okay, this is its conjugate right here. And so we'll multiply by what's called a conjugate. Scoot that up a little bit, give me some more room. So I'm going to recopy this problem. 29 minus 15i, negative 4 minus 5i. And we're going to multiply by the conjugate of the bottom. So it's the negative 4 minus 5i that we're going to multiply by. So the bottom, negative 4 plus 5i. And we're going to do that on top and on bottom. So we created a conjugate by changing the sign of the imaginary part of the problem. Got a plus bi here, it's a negative bi here. We use that on the bottom, and now we multiply the top and the bottom by that conjugate. It's going to be a lot of foiling, essentially. Okay? And don't forget, I squared equals negative 1. Okay? That's going to be key here. All right, so let's multiply. Oh, wrong pen. All right, negative 29 times negative 4. Anybody? Anybody? I have to look that up. I'm not that good. Negative 29 times negative 4. I don't have a calculator with me. 29, 4 equals that times that. So it would be negative 116. Negative 116. So 29 times negative 4, negative 116. 29 times 5, so we got to do that real quick. Change that number to 5, be 145. So 29 times positive 5. Already forgot that number. 145, 145i. Negative 15 times negative 4, so negative 15 times negative 4 be plus 60i. Negative 15 times, that was negative 15 times 4. Gave me net positive 60i right there. And finally, negative 15i times 5i be negative 75i squared. All right, so for shortcut, I will cancel the I squared and make it positive. So remember that I squared is negative 1. A I squared, which is negative 1, times a negative 75 will make us a positive 75. So I've just gotten rid of that right there. So that's the top part. We'll do the bottom part now. Multiplied by the conjugate is going to have some stuff cancel out. So negative 4 times negative 4 is 16. Negative 4 times 5i is negative 20i. Negative 5 times 4, positive 20i. And negative 5 times positive 5i is negative 25i squared. I squared makes it change sign, so that's now a positive 25. When we multiply by a conjugate, this will always cancel. Negative 20i and positive 20i will cancel each other out, so they are gone. We'll simplify some stuff and see what this looks like. Negative 16 plus 75. So you guys have your calculators. I don't have my calculator. So we got negative 116, got a 75. We're going to add those two together. Negative 41. Negative 41. No I on that. These two are real numbers. So there's no I on that. 145 plus 60i be 205i. No square because you're just adding those two numbers together. On bottom, you have a positive 16 plus 25 is a 41. Now, don't just try to cancel these two 41s. It doesn't work that way. What you want to do is try to get a number that divides into all three of these. So the biggest question here is, does 41 divide into 205? And I think it does. So check that out with your calculator. 205, 41. And yes, it goes in 5 times. So all three of these are divisible by the number 5. So we get a final answer. I'm sorry, they're all divisible by 41. So negative 41 divided by 41 is negative 1. 205 divided by 41 we saw was 5. And 41 is divisible by 41, so the denominator disappears, and you're left with 1 plus 5i. So this is the most labor intensive of the problems, but you've got 3 different categories. You got adding and subtracting is one category. The second review section is multiplication, and the third review section is this dividing complex numbers, where you need to multiply by a conjugate. So it's really just multiplication. Be careful with the signs and things here on the division. That's what will mostly get you. When you get to your Delta Math assignment, you have 5 problems in each one of the categories. So 5 addition, 5 multiplication, 5 division. We may have a quiz this week. Some of you guys did very well on the quiz last week, and it helped you out a lot. But what we are doing is we're looking at a test next week, next Thursday, May 7th. So good luck. I look forward to hearing from you guys. If you need any help, just let me know. Have a great Monday.